Hello and welcome to part 2 of the WARDJet water-only webinar. My name is Benji Macera. I'm product manager here at WARDJet, and I'm happy to have with me today Terry Craig from Zotefoams, as well as Jeff Day and Johnny Stamper, two of our applications engineers here at WARDJet. We're going to cover a number of different topics today, but at any time, if you have a question, feel free to fill that out in the chat box below, and when we get to the Q&A portion of the webinar, we'll be happy to answer those questions for you. Now, there are a few things I wanted to talk to you about this week for part 2 of the webinar. Now, one of those being 5-axis capabilities. Now, we did talk about that last week in some of the benefits of WaterJet cutting for water-only processing, but I wanted to show you it in action. So what you can see here is we've got some of the Zotefoams blue azote material, and we're cutting this on our in-house Apex 60 mechanism. Now, we mentioned that this is a mechanism that can be outfitted on any of our water-only systems and to really increase the production capabilities of your WaterJet. So as you can see, it's able to cut both 2D shapes and then quickly transition to cut that 45-degree bevel on the outside of that piece, and then back to 2D to cut the final profile of that. So you can see the finished piece is something that would be very hard to manufacture just as quickly if you weren't using the WaterJet. The other piece I want to talk about is the material stacking and common line cutting. Now, again, we touched on these last week, but on the same mechanism that we're running there, you'll see the Apex 60 running only in 2D mode here, trying to process multiple cubes. So you'll see it taking its passes back and forth and then transitioning again. What this is doing is we've got two materials stacked, both the blue and the yellow. And then we've also using the common line cutting. Instead of taking 4 passes for each one of those for that cube, we're just taking 2 swipes at it and then using common line cutting. So as you can see, as Jeff starts to unload some of those pieces, you end up with a lot of production very quickly. If we were to try to do this on a single sheet and then try to cut out each one of those cubes individually. Clearly this is a simple shape, but the basic principles translate over into whatever piece it is you may be cutting. The last issue I want to talk about this week is some of the different workflows that you can get for water-only cutting. And clearly WARDJet offers a variety and is able to cover any need. But I wanted to start off first with our J series and L series, which is really a pass-through workflow, which we saw last week in the machine that we walked through. So you'll see that we start with raw material on one end of the machine. It gets passed through, processed in the middle, and then out come your finished parts. Now what you get with this is very, very high throughput because you're able to load material, process material, and unload material all at the same time. Typically you'd find this in a facility where you've got multiple people running this machine, typically one person responsible for loading the material and starting the program, while one person dedicated to just unloading the material. With systems like this, it's not uncommon to see one warehouse space with raw material on one side, 2 or 3 employees running just a single machine, and then finished parts getting packaged and sent out to customers. So very, very high throughput. If you've got a high volume of parts that you're looking to produce and you want to run multiple shifts and you really want to get the most out of a machine, you cannot go wrong with our J series or our L series WaterJets. One of the more typical workflows that you'll see is just your standard WaterJet workflow. So with this one, you've got a single plank of raw material that gets loaded onto the machine, it gets processed, and then it gets unloaded. Now, clearly this is not going to be the high throughput that you get on some of the other systems, but this does have its place in many facilities. Those facilities may have limited space, so this is going to offer the smallest footprint in your shop. This can also be very easily run by a single person, most often someone who's programming the parts, loading the parts, running the machine, and then unloading those as well. There are ways to increase throughput on this. Multiple heads can clearly increase the volume that you can output with this workflow, but most often you'll see that in machine setups like this, you may have 2, 3, 4, up to 10 machines in a facility, all dedicated to either one application or one material, all being dedicated to one operator, or potentially there's one operator that's running 2 machines at the same time. And you'll see this kind of workflow in our Z series and in our X series machines. The final workflow I want to talk to you about is one we're going to be looking at today with Jeff and Johnny on our floor. And now this is one of our X series machines that takes that typical footprint, but also adds a shuttle table to this. So the one we're going to see today is an over-under shuttle table. We also do have pass-through shuttle tables as well, which kind of give you a little mix between the J and an X on there. So this is really semi-continuous processing, where you're still taking a piece of raw material and putting it up on the bed, loading it in, and you're operating one at a time. But the benefit of this is you're still able to load and unload one sheet while the other is processing. So typically while one is processing, you're taking the spent parts and the skeleton from the previous operation, loading a new sheet on, and then as that first process ends, you're swapping those tables in and out. Again, you get the benefit of the smaller footprint in here, not quite as small as a typical, but not quite as expansive as you'll need for a J series or an L series. The same tenets apply. Multiple heads are going to increase your volume in there. So there really is kind of a mix when you talk about this. So, yeah, looking over the different workflows that we have, it's very evident that WARDJet has dedicated a lot of time, energy, and engineering into covering whatever your application may be. So please feel free, contact us, talk to your sales rep. We're very happy to take your material and your application into consideration, as well as your warehouse and your business needs to provide you with the best water-only system on the market. So with that, I'd like to go ahead and move on to our next segment.
So whether a company opts for a system like our J series with the conveyor and the long loading unloading areas, or a series like this with the shuttle tables, depends on a few different factors. First of all, how the material's flowing through their facility. So if you've got an aisle here and this is up against a wall, you can have area here where you've got your raw material, your cut material, and this is very conducive to having one person run this machine, load and unload your material. J series, where they're a little bit longer, that's often you'll have multiple people running it, one person at one end putting maybe material on, other person at the other end of the table taking the material off. So one of the important factors when looking at a water-only system is your choice of substrate that you're going to be cutting on top of. So depending on the density of your material, the application, size orifice, pressure, things like that, will determine whether you use something like this Johnson screen or a material like a water brick. So if your part's going into a crate and the back surface isn't going to be visible, you might choose something like the Johnson screen or maybe a honeycomb, which can come in different opening sizes and widths of the webs there. If the part's going to be more visible and you don't want to see any sort of dings on the back of it, then you might choose something like this water brick here. And depending on the color of the material you're cutting, the water brick can be either white or black. So it's one of those important factors where we can do some test cuts on these different materials, and then you can choose which one's optimum for your situation. So here we have the Z carriages on this machine. So this customer has opted for 2 cutting heads. Depending on the size of the parts that you're cutting, you might decide for 3, 4, 5, 6 cutting heads. You can also get spreader bars with multiple cutting heads on there. For the head spacing on this machine, this is manual head spacing. So there's a couple cam levers back here. The operator can just very easily loosen those levers and position the cutting head to the desired distance and then lock those back down. Can also opt for programmable head spacing. So depending on the size of the parts in the program, the CNC file can automatically change that head spacing and can even change that head spacing throughout the program. This machine's got programmable Z. As you can note, we have 24 inches of Z-axis travel here. That allows us to get down to that lower table. So automatically when we switch tables, we're going to switch our limits, and then the cutting heads are going to go down to the appropriate height off of the material on the lower table. A couple other features to note here. We've got hand valves. So operators doing any maintenance on the cutting head, they can close the hand valve to isolate pressure to the cutting heads. And then one other thing to note here, on this Z carriage, we have this QR code. So we'll put these around our machines at various strategic locations, and this will link to things like videos and manuals, any sort of documentation that might help with maintenance on that particular aspect of the machine.
Our X series line of machines have custom aluminum extruded side rails and cross beams, and we pair those with a THK ball screw and linear rail. The ball screw has 2 raceways on it, and we use one of them. So in 10 years, if you see tolerances start to expand or get a little bit of play, you can switch that to the next race, and it gives you almost a brand new machine. With the THK ball screws, linear rails, and the aluminum extruded side rails and cross beam, we pair that with a large motor and gearbox combination, and that gives us the ability to hit speeds up to 1,000 inches a minute and acceleration rates up to 15 inches per second squared.
Okay, we'll go ahead and run through the basic workflow on this machine. So we've already got material loaded on the top table, so Johnny can press the release button and push this table in. So obviously this machine is a manual system, but these tables can also be powered. So that once these tables are locked into position, he can then run the program. Controller has a couple things going on here. We've got head leveling, so head 2 is always going to come down to the same height as head 1, and then we're working off of a work offset position, which establishes our height off of the material, and also depending on whether we're using the top or bottom table, we can have different Z heights there. So once the program finishes, then again we'll be able to release the tables, swap them out, and continue on with the process. So that program's done, we release. So now we're running the same program again, just hits continue. And now the controller knows that the lower table is in, and it'll drop down to the appropriate height off of the material that's on that lower table. One thing to note is that while the machine is cutting and while those heads are down below the top height of the lower table, I can't release this, so even if I press that release button, these remain latched in place. And also at the end of the program, if the operator doesn't bring those Z carriages up high enough, we won't be able to release the tables. So it gets a warning message saying to raise the Z carriages. Once those Z carriages clear the top of that top table, then those latches release and we can swap the tables.
This machine has a slope bottom design that allows the kerf material and the wastewater to go back to a centralized point in the back of the tank. It also has been stainless steel lined to hold up to years of abuse of the water. It has a built-in washdown system that pushes that kerf material to the back of the tank and down that drain point. As the water exits the tank, it goes into a sump pump tray. The sump pump tray has a stainless steel grate to catch any large media. As the water comes through, it fills the tank. The tank then has an electronic sensor here that activates a timer, that activates a pump to pump the water down and out of the tank. That water can go to a paper bed filter, to a drain, or anything the customer is looking to do with it.
Thank you for joining us. We hope that you enjoyed this. As you can see, WARDJet offers a wide array of options and accessories that can be custom tailored to meet your application.
Hello, my name is Terry Craig, and I've been asked to speak with you about a family of materials that is produced by a unique process. Zotefoams offers a range of high-performance, lightweight, cross-linked polyolefin block foams known as Azote that are among the purest, most consistent, and technically advanced cellular materials on the market. But first, a bit about my credentials. I've been in the foam fabrication industry for over 35 years with direct experience in automotive, aerospace, mass transit, medical, defense, electronics, and of course, product protection. My career has spanned operational and executive roles in quality assurance, manufacturing, product engineering, design, and business development. I've worked with Zotefoams materials since the early 90s, and today I want to share some of the advantage of their products from a fabricator's perspective and how these advantages can help you to grow your business. It all starts with an understanding of Zotefoams' unique process. Most cross-linked polyethylene and copolymer block foams rely on chemical blowing agents to create a cellular matrix, and those blowing agents can introduce volatile organic compounds, which become latent and residual in the foam material. Zotefoams' azote materials do not use chemical blowing agents, instead use high purity nitrogen, which is among the most common elements in the universe and is generally considered inert. In fact, it makes up approximately 78% of the air we breathe. So how does Zotefoams produce foam from nitrogen? Well, it involves a unique three-stage process. Stage 1 is extrusion and cross-linking, where polymer and additives such as colorants, fire retardants, or conductive agents are extruded into a solid, continuous plate, which is cross-linked, cooled, then cut into slabs. Stage 2 is nitrogen saturation, and this is where the science begins. Slabs are heated above melting point and infused with high-pressure nitrogen gas. Rapid depressurization at a controlled rate causes nucleation of the cellular structure within the slab, and subsequent cooling while under pressure locks in the nitrogen. Temperatures in the autoclave reach above 250 C or 480 F, and pressure can exceed 670 bar or 10,000 psi. To put that in perspective, that's the pressure of water more than 4 miles beneath the surface of the ocean. Stage 3 is expansion. By heating the slabs under moderate pressure and then reducing the pressure, the locked-in nitrogen is allowed to expand. Important to note is in this process, expansion is unconstrained and uniform in each direction. There's no physical mold or platen that can cause densification along sidewalls or from top to bottom within the block. This is a very important distinction which contributes to several performance characteristics which I will describe in detail. How does this unique process benefit the use of the material, and specifically its fabrication? First, from its purity. Low outgassing, low VOCs, no residual blowing agent, and low fogging means you have the ability to provide protection of devices and instrumentation that contains sensitive optics, lenses, and electronic circuits without concern for fogging or staining. Coupled with very little odor makes these materials perfect for sealed bag and case products such as supplied in medical kitting, product protection, and case inserts. It also enables you to meet stringent interior emissions requirements for human occupancy applications such as in automotive, aviation, and mass transit. It is also excellent for direct skin contact in medical and sports products, meeting international standards for skin irritation, sensitivity, and cytotoxicity, and its closed cell structure prevents moisture and fluid ingress while suppressing bacterial growth. Purity also produces foams with the whitest whites, the deepest blacks, and vibrant colors, all providing unparalleled choice to suit the end-use product. Consistency. The Zotefoams process enables control of the cell size. Combined with unconstrained expansion, the cell structure is considered isotropic, meaning predictable performance no matter what direction a stress or strain force is applied from. There's no machine direction cellular orientation, no elongated cell structure, and no density stratification through the block. From top to bottom, across the full width and length, the material will process and behave the same. For applications involving comfort or protection, this means product performance will be uniform, consistent, and predictable no matter the orientation that the material is used in. Unconstrained expansion also means low built-in stress, which reduces the potential for distortion during processing and in the final product. Have you ever split a bun into sheets and then discovered that the overall dimensions change or the squareness of the sheet becomes distorted? Zotefoams materials are dimensionally stable as received. Important to throughput. It does not need to be split into sheets, then stored anywhere from 24 to 72 hours or more to allow the material to relax and normalize. And unlike chemically blown materials, Zotefoams products do not need to be pre-split to allow outgas of any residual blowing agent. Now let's talk about performance in processing. Uniformity and controlled cell size produces consistent, finished product with clean, smooth edges and with surfaces that are more resistant to marring and scuffing than most chemically blown materials. This is often important in case inserts, display packaging, medical, and sports components. You can achieve high quality, intricate, and precise geometry with unsurpassed surface appearance, be it through CNC machining, Waterjet cutting, die cutting, hot wire or abrasive wire profiling, or virtually any manner of fabrication technique. Zotefoams materials are also easily thermoformed, heat laminated and bonded with throughput speeds and yield factors that are among the best in the industry. Often, lower density materials can outperform higher density competitive product while providing savings in weight and in overall component cost. We've talked about the material, now let's talk about Zotefoams, the company. They offer the widest range of block materials on the market, including low density and high density cross-linked polyethylenes, VAs and EVs, along with fire retardant, conductive, static dissipative versions, and specialty polymers including nylon, PVDF, and TPE. Zotefoams has the ability to tailor the dimensions of their products to achieve optimum dimensional yields on high volume applications. This reduces material content, increases production throughput, and importantly, reduces waste. Supported by decades of technical experience and documentation geared specifically for regulated industries, including automotive, medical, defense, and transportation, Zotefoams acts as an extension of your sales and technical departments. Being onshore produced with a controlled distribution network, the logistics benefit include LTL shipments, no upfront costs associated with placement of offshore container load orders, reduced inventory, and importantly, increased turns, putting cash flow back in your wallet. To summarize, unique process produces unique materials, pure, lightweight, consistent, and visually appealing materials that process with ease and speed, and in combination with product range, technical support, and onshore logistics, enables fabricators to grow their business in virtually every major market and application. To learn more about the extensive benefits of specifying and processing Zotefoams products, please connect with us through zotefoams.com. We will be very pleased to answer any questions you may have. Thank you for your time today.
Okay, hopefully you all enjoyed that. We've got our question and answer session now. So we've also got Dan from Zotefoams on the on here if anybody's got any questions specifically for Zotefoams and their material and such. Dan, you hear me okay?
Yes, I can hear you fine. Thank you, Jeff.
Great. So one question came through was any particular industries that you see are doing well right now?
Well, I mean, we're a pretty diversified company, but we're seeing some very nice progress in construction, health and beauty, in terms of medical, and in particular, there's definitely a surge right now in PPE types of masks, and the shields remains a quite buoyant, unexpected type of a segment application that we haven't historically seen a lot of demand from.
Great, well, that's good to know. So, another question came through is why would somebody choose a system with a chain like the J series versus a shuttle table system, say with water brick? And oftentimes that comes down to either the size of the parts that somebody's cutting or the type of material that they're cutting. So for example, if somebody's cutting very small parts, probably not going to want to cut something like this on the chain system because they'll end up falling through the chain unless you tab them in and then you've got to break them all out. So something like this, you'd probably want to cut on a water brick table. Now that doesn't mean that you can't cut it on a system like a J series with the chain, because you could always take something like we have here, a tray that has the corrugated plastic water bricks in it, and you could lay your material up on that and basically use the chain conveyor as a shuttle table and shuttle this into the cutting area. So if it's only periodically you're doing something like this, you could still go a chain system and then use the water brick for that. And then the other thing is very light materials may flutter when you're cutting it on top of the chain with that back pressure. So then again, you might want to use some water brick like this if you're doing that periodically. But again, if it's something you're doing frequently, then you'd probably opt more towards the shuttle table system with the grates. And then questions about we make small metal parts. How do we make cavities in the foam for shipment? So usually people will do several layers. So you have a base layer that might be thinner, more rigid foam or plastic, and then There's software packages out there. We have one through iGEMS where you can take in your shape profile and basically create a silhouette of that shape and then cut it out of the foam. Some people will have a light box, so they'll have some opaque plastic, lay their parts or tools. You see this a lot in the aviation industry when people are doing like engine repair and they have to keep track of all the tools. They'll have a light box, they'll lay out all the parts, all the tools on the light box, take a picture of it, and then you can bring that into software and create the cutout for that. So that's quite a popular thing for water only cutting. And then this question about why would you choose an over-under versus front-to-back shuttle table system. So in the video, we saw the over-under shuttle table. As Benji mentioned, we also do a front-to-back shuttle table system. So a couple factors that can come into play there. Number one would be the amount of room they have available. Also, if your material can't get wet, if you're doing a open cell foam, maybe the over-under table, you might get some water dripping from the top table onto the bottom table. So that's one thing to look at, why you might choose the front to back versus the over-under. If you're doing a steady diet of very thick material, you might opt for the front to back. On that machine that we saw on the video there, that bottom table, you can put material up to 4 inches thick. The top table, you can do up to about 6 inches thick. So if you're doing a lot of material 6 inches and thicker, then you might opt for the over under, and then you could do material, stack it up to almost 12 inches high. If it's only infrequently that you do material thicker than 4 inches, then you could always just do the thicker material on the top table and just pay attention to that. And
okay. Yeah, if I can
yeah.
just add, another reason to go front to back is putting multiple sheets with multiple heads. So you could put, 3, 4 by 8s and load them and then run them right through the whole system. The over-under tends to be one sheet. So,
Right.
or several smaller sheets. You could have multiple heads, but it would just be smaller parts as opposed to full sheets like you're looking at there.
Right, now this one doesn't have the shuttle table system on it, but we have done many systems like this that had the shuttle table system going front to back. So slide the table in with 3 sheets, cut the 3 sheets, and then out the back and forth. So very productive systems. And do different densities foams cut differently? Yes, absolutely. So your 2 pound, 4 pound foams, you can cut those at virtually as fast as the machine can go. And then as you start getting up into your 6, 8 pound foams, then you've got to slow down. And of course, also depends on the thickness of material that you're doing. If you're doing 4 inches thick of 8 pound foam, you might be cutting at 25 inches a minute versus 1 inch thick 2 pound foam. Again, you can go 2,000 inches a minute. And then you have to balance that with the size of your pump and the size orifice. So all those things we can test out if you're interested. Typically people send us material, stack of material, different densities and thicknesses, and we'll slice across it with different orifices and pressures and speeds and send them back to the customer, and based on their application, they can determine what's best for them. And last week, somebody had asked, which I thought was a good question that I'd bring out again, is do we recommend diamond orifices? So for those of you that aren't currently doing WaterJet cutting, the orifice is the thing in the cutting head that converts your high pressure stream up here to a stream moving at 2,000, 3,000 miles per hour down here. So this size of a hole in this orifice can be anywhere from 4 thousandths of an inch up to 14 thousandths of an inch, again, depending on the application and the number of heads and size of the pump. And those orifices can be made out of different materials, rubies, sapphire, or diamond. As you can see, the rubies and the sapphires have relatively short life when it comes for somebody that's doing water only cutting. So as you can imagine, if you had a system that had 4 cutting heads on it and you're running sapphires and each of those is failing at a random range between 0 and 80 hours, you're constantly going to be kind of chasing your tail, changing out the sapphire orifice, whereas the diamond orifice, they are a bit more upfront, but on an hourly basis, they end up being cheaper, and you can just put them in and not worry about them for several months at a time. And it also reduces your downtime for maintenance. So definitely would recommend diamonds for water only applications. And question about cutting angles or chamfers and such on parts. So that's a big part in the water only industry now. Seen that coming on a lot in the past few years. So with our 5-axis heads, you can put angles on there. So I know a lot of people doing returnable dunnage and such, they'll put maybe just a slight 5 or 10 degree angle on the outside of the foam so it can slide into the crate easily. In the video that we showed earlier, we showed it putting a 45-degree bevel around the top of the part. So it's certainly a growing aspect of water-only cutting. Of course, one key factor when it comes to the results of that is flatness of the material. So if your material is wavy like a potato chip, you're not going to get as a repeatable result as if it's nice flat material like the Zotefoams material. And let's see, question about what are some of the more interesting things that you've cut water only? So obviously talking a lot about foam and things. I'd say over the past almost 12 years I've been here, a couple applications come to mind. We had one person who was interested in using water only for basically in a butcher house to chop up cows. That was kind of interesting because we had to go down to a local grocery store and buy a chunk of meat and put it up on the table and slice across it. But that project went nowhere. Also, I've cut pig heart tissue, which was pretty interesting. So it's probably those ones that have some sort of biological matter involved that tend to be the more interesting ones. So I guess I would pose a question to the audience, and if you like, you can respond to us via email. You can email me, I'm jday@wardjet.com, but just be interested to see if there's any particular things that you'd all like to see on future webinars. So always want to make sure that we're doing something that's interesting to the audience. So if there's, and it doesn't have to be strictly water only cutting. So if there's any thoughts about things that you'd like to see, drop us a line and let us know. Richard, do you have anything else?
No, that's been great, thanks.
Okay, well, appreciate everybody joining us today and look forward to seeing you on the next one. Thanks.
Thank you.
Yeah.